and welcome to another Commodore 64 assembly programming video. Yes, it's been quite a while since my last one. COVID, lockdown, working a lot from home, and I'm having to do a lot of intense programming in my day job, so the last thing I felt like doing was any more programming in my spare time. But that being said, it's been long enough, so I am back with the next instalment. Today we will be looking at programmable characters for graphics. As you know, with the Commodore 64 and the VIC-20 and the PET, you've got the standard character set, which is A to Z, as we can see here, A to Z, uppercase, lowercase, and we've also got the Commodore characters, which you can access by doing Control and Commodore key as well to bring these up. This is all you had on the Commodore PET. You have to make your graphics using all these shapes. I mean, I've only put a few of them down on there, but there was quite a few of them. But it was limited. So, what you can do on the VIC-20 and the Commodore 64 is to actually design your own. Which is very, very handy. The sky's the limit, basically. If we look at most sort of older games, like this one, which is Manic Miner, you can see the levels there are all made with custom graphic characters. So how do we do these? Right, okay. So, first things first, there is 3 modes. So you've got the standard high-res mode, which is exactly what you're seeing in front of you now, which is monochromatic. Basically, there's one colour in it, or whatever colour is in the colour memory. I mean, at the moment it's bright blue. We can change that by poking values in the colour memory, or putting characters codes in. But there's only one colour, whatever colour is in the colour memory at the time. And this will ensure that you do get the full resolution of each character. So it's in an 8x8 grid, every single character. So if you can see the flashing cursor there, you see it's 1 pixel deeper than the letters. That's so we get a line of separation between the letters. That's high resolution. The second one is multicolour characters, where you can have more than 1 colour in the character. I believe it's 2 colours in the character. I will double check that. However, the definition is a lot lower, so it's only 4 pixels wide. So a bit like sprites. If you've got colour sprites, you lose some horizontal definition because it's got the colour codes in there. And the third is sort of a mixture of the two. So what it is, it's a single colour character in high definition, like we can see in front of us. However, you've got the option of 4 different background colours on it. But you're limited to 4 times less the amount of characters you have. So they'll basically, rather than having 256, you have like 64 characters. And then the highest bit, I think it's 2 bits actually, is where you choose the background colour. However, we will go into that more when we start programming it. I'm just reeling this off the top of my head at the moment. So the first thing we will look at is programming the high definition monochromatic one, like you see here. So let's get back to the development environment. Right, here we are in our development environment. The first thing I'm going to do is just do my usual importing of my constants. I've got 2 files. I should really sort of consolidate them into one. Vic2 constants.asm, and we'll do our basic up start 2, and we'll do that at the start label, which we haven't got yet, and we'll start our program at hex 1000. Here's our start. So first thing we'll do is make our screen black. Nice having these constants here. Store that in the screen colour as well. We'll load in white, and we'll store that in text colour, which is hex 286. And we'll JSR CLS, and down here we'll do a RTS. So this should turn our screen black and give us some white text. So let's just save that and run it. Oh look, I've made a typo already. It started off well, hasn't it? There we are. So how do we use a custom character set? So there is a nice little register, which I'm about to show you on here, on this Commodore memory map. You can see we've got D018 or 5372 memory setup register. Okay, and we will point to a set of character memory relative to the VIC bank. So I've been reading the Commodore 64 Programmer's Reference Manual. I said the safest one to use in BASIC, which we're not using, is address 3000. So if we look here, bits 1 to 3 we're not going to be using, bits 4 to 7 we are, which is 3000 is 1100. Okay. So we're not going to touch the first 3 bits, or the first 4. So we're gonna change the last 4 to 1100, which will put our character, which will point the computer or the VIC chip at 3000 to get our character set. Let's look at our address. So it's going to be, there's our 8 bits. Okay. So what we want to do is keep these what they are, and we want to change these last 4. So we want to make this like this. So how do we do that? Well, it's very easy. First of all, to preserve these, we just and this portion of the byte. So we will AND it with that at first, and it's very easy to see what you need to do here for that. I'll show you. You just go to the calculator, okay, and we'll put that in, and we find that that is 240 in decimal, or F0 in hex. So we're going to AND it with 240, and then to get this, I mean, this looks like, here, this looks like the number 12 to me in binary, so we will just add, because this is going to be 00 once we've ANDed it, we'll just add 12 to it, and that should do exactly what we want. So whatever's in here doesn't matter. If we AND it with 240, sorry about the mouse movement there, I'm still getting used to this magnifier. We AND it with 240, add 12 to it, we should get, they're preserved, and that's what we want to point our character. Oh, and 240. We AND it with 240, add 12, and we should get this. Whatever is in here, okay, in either of this, these ones marked X will be preserved, and this will be like this. So let's do that and see what happens. So the first thing we do is load that value into the accumulator. Now if we look at our constants, pick two constants, it's here, graphics pointer is already defined, which is D018. So let's copy that and go to here. Load a graphics pointer in. Okay, we want to AND it with 240. Not the address 240, the number 240. So we put the hash in. It's decimal, so we don't put a dollar. So we AND it with 240. That will preserve the first 4 bytes and leave us with 0 for the last 4, and then all we need to do is add 12 to it. So we need to use the add with carry command to number 12. Before we do that, it's always sensible to clear the carry. And then store that back into graphics pointer. So this should point our VIC chip at a different address to read the character data from, instead of the ROM where it normally gets it. So let's see what happens when we run this. And we've got a load of garbage, which is right, because we haven't defined any characters there, and we haven't copied the ROM ones there, so we have got absolute garbage, which is what you'd expect. So now we've got a nice fresh bit of canvas for our characters. Let's design a character. So the way I'm going to do this, I'm going to use a sort of similar one to what's in the Commodore 64 Programmer's Reference Manual. Let's create an 8x8 grid. So one dot either side. It's 10 of these. Yeah, is it 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, this is going to be our 8x8 box. Let's do the space. We'll put ones in. 1, 2, 3, 4. So there's our first line. There's our second line. No, that's not good. That should be there. Third line. You can see what I'm doing now, surely. What an artist I am, eh? We'll just finish that. There, so as you can sort of just about see, we've got a nice nice smiley face there, which is probably something similar to what was in the Commodore Programmer's Reference Manual. Right, so how do we turn this into a character? Well, the reason I use the number 1 is this way, because I've got a sort of way I've invented to make it easier to turn these into binary. So what we'll do, I'll just change all the spaces for noughts. It doesn't take long, there's only 8 rows. Nearly lost that one. Yeah, I have lost that one. Undo. That's it. And okay, and here we have it. These are our binary numbers we're going to use. So you can use your calculator on your computer to convert decimal to binary. I can put them in now because I know what they are. So this is binary for 60. This will be 66. Oops. Helps if I could type. 165. 129. 165 again. 153. 66 and 60. So how do we get these into our program? Well, simply we just put them in the memory. So we've changed our address to 3000 for our Vic characters down here. So we want to change the letter A, for example, so it is this smiley face. So it's not character 0 because 0 is the @ symbol, and that's a pain to do on the emulator keyboard. So A is the next one afterwards, character 1. So that would be hex 3008 because 3000 to 3007 is the 8 bytes for the @ symbol. So let's just put that here. It's hex 3008. And we'll put these numbers in: 60, 66, 165, 129, 165, 153, 66, and 60 at the bottom. We'll delete that. Now, as you can see, we've set our memory pointer to 3008 and we're just cranking these numbers into there, so we're loading it into the memory. Let's see what happens. Oh, look at that. So the A in ready has already produced our smiley face. Look, I'm hitting the A key now and we've got it. So let's just do a quick bit of code to print a row of smiley faces. So there's 40, isn't there, in a row? 40 in there. Let's create a loop. Okay, so we'll load the accumulator. It's character number 1 because it's A, so it's not 0. Decrease X register. Oh. Oh, I hate this IntelliSense sometimes. Decrease the X register. Screen mem is in our constants file. So this will do it backwards. So I do it from right to left, but it's just slightly less code. And if it's not 0, go back to the character loop. That's it. So we should have the top row full of smiley faces. There we go. Obviously the ones underneath are ready. I can type that READY full stop. So yeah, I do get that. So there we have it. That's the first part of programmable characters and the standard high resolution ones. Right, one thing we might want to do before we finish on high definition characters is as we've only got the our little custom one, we might want to actually copy some of the characters over from the ROM and use them. So how are we going to do that? Because we can't actually read off that ROM in the in standard mode. It's only read by the VIC chip. So there's a little trick we've got to do. So let's just point you at the memory map. Now if you see memory location 1 here. Okay, now if we look, if we change this bit here, whilst preserving everything else, that will make the character ROM visible at this address here. So what we need to do is we need to preserve everything else in this byte and change this to a 0. So we will use our ANDing to do that, as we've done before. So let's pop in and have a look, and so we need to do this sort of right at the start. First thing we need to do is turn interrupts and keyboard scan off while we do it. Okay, we will load the contents of the memory address into the accumulator. And what we need to do is we need to preserve everything. So if we 2, 4, 5, 6, 7, 8, we need to preserve everything except this bit here. So the way we do that is this number in binary is 251. So we'll AND with the number 251, which will preserve everything, and it will just ensure that bit we want is 0, and then store that back into the accumulator. Store that into 1. So now what we need to do is copy. I think we should only copy, say, the first 256. There's 512 all in all. We'll just do 256 for now, so we should get all the letters and a few other things. So we want the letter A, don't we? And we've already overwritten that. So why don't I, if we scroll down to here, well, let's set this as character 0, which is the would have been the @ symbol. So we'll make that character 0, and we'll this loop here that prints a line of them, we will load that with character 0. So we've now changed it from character 1 to 0. So back to here, let's loop through everything. So if we load the X register with 0, create a loop here. We will load from D000 with the offset, which in my constants is down as the VIC base. So it's going to loop from 0 to 255, so it will load 0 there, and then we will store that in 3000. And then we'll increase the X register, and until it hits 0 again, we'll keep repeating. So, what's wrong with that, you say? We're basically going to overwrite what we've defined here, which is the first character, which is the first 8 bytes. So, to get around that, we will just start our countdown from 8 instead of 0. So 0 to 7 will be missed out completely because that's our custom character. And we will start from 8 there. So once we've copied the characters into our custom character set, which starts here, we just need to reset that bit back. So we will load the accumulator with the memory address from 1 again, but we will set that bit now. So we do that using OR, so it will leave everything preserved and make the bit 3 1. So or bit 2 0 1 2, yeah. So we will OR it with the number 4. Oh. And store it back in 1, and then we finish that, we will restart the interrupts again. So we stop them here, so we go down and restart it here. So that should copy 255 characters over from the ROM. Then we'll turn the ROM off again, which we're doing here. This here is turning the character ROM visibility off again, and then CLI should get the Commodore 64 back working as it should with the interrupts. So we will give that a go. There we go, and look, we've got the word ready now. Quick brown fox jumps over the lazy dog. And we've got our normal characters as well. So that brings us to an end really for the higher resolution monochrome custom characters. The next thing we will be looking at is the multicolour characters.